Hello everybody and welcome back to From Rhythm to Algorithm Part 23, Completeness. I'm not going to do much introduction, more math, more physics, more linguistics. Picking right back up from Part 22. But obviously in this video we're going to try to get a better logical, mathematical, linguistical handle on the concept of completeness. So biological uniqueness, we're all different people. Everyone's an individual, you can't deduce the individual past the individual. Establishes irreducibility. How does that manifest linguistically? A complete concept cannot be reduced, right? What am I sitting in? I'm sitting in a chair. Big historical philosophical question, what makes a chair a chair? Well, it's the function, how someone uses the thing. And then now, that's the conceptualization, and the formalization of language is literally just a bunch of people using the word based on the past words that already existed and modifying the syllability. So, horseshoes and hand grenades, right? There's a saying, close only counts in horseshoes and hand grenades. False. And in language. And the way you can see that is reading theorems, right? So again, I don't know exactly how to say this correctly, but I'll just give you an example. Discovery is not recovery, right? Do you agree with that logically? Yes. What's the difference? Recovery is to get something back. Discovery is to figure something out for the first time. Now let's read that sentence backwards, but the word order backwards. Recovery not is discovery. It's kind of awkward, kind of clumsy. Doesn't really make sense. Let's try another sentence. Good acting is not acting. Think about that logically. Is a good actor, can you tell they're acting? No, they're being genuine. So that's logical. Again, this sentence, all we do is we change the prefixes and the suffixes, which we've covered in detail. But this is interesting because again, right, we have our statement of equality, not our empirical value function. The same variable, prefix, variable, suffix, and that changes the logical statement and it creates a logical theorem. But now let's read good acting is not acting. Let's read that backwards. Acting not is acting good. See how that still produces a fundamental theorem? That still actually makes sense, as opposed to recovery not is discovery. That doesn't make any sense logically. So, and again, here's just again random theorems I have sitting around. But I haven't read these in a year, well over a year. I'll just read some now. This is not super in line with this. Well, the idea is courtesy is polite, polite is courtesy. A shop is a store, store A is shop A. So, speciality, we've talked really in depth about biology, about psychology, but when you exaggerate language, a fundamental theorem, the fundamental stability of two, you can read a theorem forwards and backwards, and it makes sense. Conversely, the more words you use, like that one I just read, store A is shop A. That doesn't make any sense. So, like, something, and you can see this very, very often with bad headlines. You'll read a headline of a news article and you have to read it 2, 3, 4 times to figure out what the person was trying to say. So you take any sentence, you reduce the word or you flip the word order. If you can read it properly and it produces a logical statement, it's a fundamental theorem. Any string of words. So I noticed that's pretty interesting. But horseshoes and hand grenades. That's why close counts in language as well. But it's the direct when you can't read any order of words backwards, it's irreducible. Like you can't deduce a complete concept. You can't reduce a logical theorem to a different concept. So, to me, that was a very, very poignant example, and that shows the direction and logic. But now how about this? Read these two words, content, and then the same word. All right, I'm making a YouTube video. I'm making content. When I was on a date with Mark Cuban's wife the other night, I was very content. So, yeah, I don't know what to do with this part, but again, you can see you just inflect a different part of the syllability, and it changes the word. Not even the word order, not even a prefix or a suffix, not even conversation or conservation, literally the inflection of the tone. So that was a great example. But a completely, now that's for sentences. Now let's again deduce sentences to words and syllables. A completely general word cannot be divided. This is our logical introduction to division. Like speciality, the word we've already established, I've already proven, and then sensorality, the word we're trying to deduce now. But again, I've said the preservation of dynamic. If you pronounce a word correctly, do you speak another word? I'm still not clear on the mechanics of that. Here's an example. Iterate. Iterate. If I break that word down into 3 syllables, the third syllable, I still pronounce a complete word. Iterate. Right? I pronounce it as well. But I pronounce a complete word in one single syllable. Now, rational. Right? Rational. I pronounce shun. Rational. But I don't pronounce ration, well, as one unit of syllability. But I pronounce shun, but shun, the word's the same, but T-I-O-N is not S-H-U-N. And S-H-U-N is the word that I speak. So what exactly about syllability is reduced? Right? Rate. I'm still pronouncing 2 R sounds. So I don't know what's going on there. But now, right, vibrational. If I put a V-I-B in front of this, it changes the pronunciation of the A from rational to vibrate, from A to A. So again, I don't, just examples of syllability, and I'm not sure the preservation of dynamic. Is it like, again, what do I say about, do I speak a complete word in a given unit of syllability? Like one syllable produces a whole other word, or does it have to have the same letters, or, again, I just don't know. But that's, those are very good examples. And now we're going to talk about how we, again, try to connect this to a geometric argument and to some other ideas. And again, I think these will be, very informative, because this is truly me trying to deduce a proof. This is not me joking. This is the stuff I do not know. But where were we at? So we demonstrated all the linguistics. Now we're going to try to talk about some chemistry, some physics, and some geometry. So how to solve chemistry or the periodic table. Right? We have some order of words called order of elements called the periodic table. I've also seen there's been initiatives to redo that. I think we will. Again, I still don't know what to do, but once we solve in complete generality how syllability expands and contracts with prefix, variable, suffix, it'll give us a direct intro, or not intro, but solution or reorganization of the periodic table. Again, we need the right top-down approach. Like I said, chemical molecules. How do we name molecules of chemistry? All of the prefixes and suffixes will be like truly a complete solution to that. But that's not going to be super enlightening in terms of, like, again, building a new engine or which materials build the preservation of dynamic. Again, I just don't know. But this will be a very good research project. But now, right, we've made a rather big claim, or we've proven a rather big claim that context defines variable, that similes use like or as, and metaphors are direct contextual mappings. So we'll talk about maps and covers, again, trying to be super specific about the terminology. But what we can now do is say, how do we connect exercise ontology to fundamental physics? I go to the gym, I lift weights, that is clearly movement. I clearly use tension, I use rhythm, I use sets, I use supersets. Do you lift, bro? Obviously I freaking lift, bro. But what we can do is say, what words do we say about motion in the gym, and how does that apply to fundamental physics? Because they're both motion, right? And we've shown the the non-uniqueness of the domain of quantum mechanics. Anything that's small should have scales because of fractals and because of iteration to the larger scale, to the larger size. So what words about exercise ontology could we use, right? Eccentric motion versus concentric motion. Concentric motion is when you're loading something. If I do a squat, it's when I squat down. Eccentric is when I lengthen or extend my muscles, right? And then bam, eccentric and concentric. Eccentricity in astrophysics, or not astrology, but astronomy, is right, a sphere. A perfect sphere has an eccentricity of 0. However, now if you're a planet orbiting a sun, how much does the mass of your solar system displace the perfect sphere? The displacement from the perfect sphere, however oblong, you know you'll become an oval, that's eccentricity. And then that's a clear, again, you're literally just extending, expanding the syllability of a known word with a direct, logical, physical definition. And now we're back, we go from going to the gym into direct astrophysics. The concentric, concentricity, concentration. What's that? All right, in the gym, it's very clear. It's when you extend it's when you release your motion. It's when you extend your muscles. So what's concentricity? How do we connect that to astrophysics? How do we extend that argument? Right, concentrated, locality, something like that. But this is going to be the solution, or this is going to again extend tremendously our logical arguments. Now for maps and covers. Just I use mapping and covering interchangeably. They're not clear to me. A map is a set of directions. A cover, right? When I was under the covers with Mark Cuban's wife on that date that I was very content on, there's something over me. So we're going to try to define maps and covers. Like I said, a map is how you logically or mathematically. We're going to say map is how you translate something, and cover is covering. Conceals, covering, I would still say covering maps, like as a fundamental theorem. What do I mean? Right, I have a triangle. We can't reduce words and concepts or individuals. Can we reduce a geometric shape to another complete geometric shape? That is a regular shape. So if I take an equilateral triangle and cut it down the middle, do I get another regular shape? No, I do not. How about a square? No, I do not. How about through the vertex? Maybe. Fuck. I don't even know. Like that, there's clearly an answer. I didn't even look it up. But, fuck me. But if you can reduce, like a hexagon, you can reduce that to 6 equilateral triangles. Right? So if you will define a complete map geometrically, is if you can take a regular object and reduce it to another regular object, a set of equal regular objects. And we'll say one that you can't is irreducible geometrically. So a complete map describes the entire physical space of a geometry. So irreducible objects cannot be complete? Maybe something like that? I don't know. But again, just trying to develop the geometric arguments as a result of irreducibility. And again, maps and covers logically are not clear to me. I don't know the difference. Another thing that's not clear to me that I use interchangeably, that I don't know, the word group, the word category, and the word set. Again, I just don't know what to do with them, but I use them interchangeably. And now we'll finish up with a little bit of physics. So now just to finish up and continuing, again, talking about the things about physics that I don't know, that are not clear to me, I want you to pace across the room. I want you to pace the room. Pace around the room. Just pace. Did you turn? Did you turn your direction? For whatever reason, the word pace to me, if I told someone to pace the room, that implies turning. That implies direction. So maybe we can take the word pace, and that's the correct word for rotation, or cycling, or cycling is pacing. Right? If I'm a cyclist, I'm riding a bicycle. Am I pacing? No, not really. I don't know. But to me, again, that velocity magnitude and a direction. Speed, magnitude. Pace, magnitude, direction, change. Again, I just don't know what to do. Velocity, obviously, as we've talked about that word, but again, do something with it, Brad. Make it awesome and cool real fast, I don't know. But now I just want to end by stating the fundamental theorem of physics. Remember I said these things iterate all the time, they change for me. When you see my actual derivations, I mean, they change, I don't know, dozens of times, like 20, 30, 40, 50 times during derivation. But we'll simply make the statement that the fundamental theorem of physics, the most general statement thing you can say about physical objects or physical systems, is vibration is not movement. And again, a physical proof requires no words, no explanations. Look around the room. Everything that you say is vibration is not movement. When you go out into the woods, the things you notice is movement, not vibration. So again, I don't know what to do, how to progress that logically. Typically what I do, right, again, the thing that I'm very good at is linguistical derivation and logical understanding. So I'll just take this statement and just start, I'm really a brute force type of guy. Like, brute force in terms of like a hack. If I was going to go hack a computer, I would be the guy that just guesses all of the passwords. And it just doesn't seem like possible with other people, but it's really what I do. So I'll just swallow this statement up with linguistical derivation, which isn't that insightful to other people, and then deduce something physically. But again, the proof is looking around the room, and the light you see, or the light reflected off that object, that's vibration. We said that has no momentum, it's not moving. So I have to look around the room literally and tell you a fact, and it has to already be true. It has to already be proven. You just have to go, ah, of course, why didn't I see that? Oh, eureka moment. Oh, the light bulb moment went off. But that's what I wanted to end with here. Thank you for those are the last thoughts for this one. Thank you for watching From Rhythm to Algorithm, Part 23, Completeness.